Hey folks, so this is section 9.4 and we're going to be talking about inverses. The first thing that I want to remind you of is a phrase that I've taught you earlier in this semester, and that is inverses find what? What is that blank that we've been filling in all semester long? Well, you remember that inverses find angles. Now, I'd like to show you some notation where this is true. You have not seen this notation before, although you have used it a bit in your calculator, so it shouldn't be too much of a surprise. Notice that over here on the left, we have the statement sine inverse of B is equal to angle A. And I say that that's angle A because inverses find angles. So the sine inverse of B is going to find my angle A. If I were to write this in the normal way, the way that we're used to without the inverse notation, sine inverse of B equaling angle A would be written sine of angle A is equal to some number B. So you see here that we have sine of angle A is equal to some number B. And we could do the same thing for cosine inverse. In fact, we can do this for all 6 trig functions. I'm only going to do it for the first 2 instead of being redundant and doing it for all 6. But this works for all 6 trig functions, not just sine and cosine. Now, I'd like to talk about some restrictions that are going to be on the inverse functions. There's 2 major restrictions. The first restriction will only occur with the sine inverse, the cosecant inverse, and the tangent inverse. These 3 all have the same or at least very similar restrictions. And so the restriction here is that anytime you're looking for an angle and you're using sine inverse, cosecant inverse, or tangent inverse, all of the angles that you're going to find must lie in the interval from negative pi over 2 to positive pi over 2. That's in radians. If we were working in degrees, of course, you know that's the same thing as negative 90 degrees all the way up to positive 90 degrees. Now, there is a little side note here. You're really never going to run into this, but I just need to make sure that the math is correct. And that is for sine inverse and cosecant inverse. Notice that we are including the end values of my negative 90 degrees and my positive 90 degrees. But for the inverse tangent, I cannot include those end values. It's just a side note to make sure that the math is correct. Now, what exactly does this look like? When I'm looking for an angle, which angles will I find when I'm working in sine inverse, cosecant inverse, or tangent inverse? You'll find that I'm starting at negative pi over 2, which is down at the bottom of my circle, and I'm going to go all the way to positive pi over 2. So the only angles that I can find are going to be on the right-hand side of the circle. Now, please don't misunderstand here. I understand that this is quadrant 1 and quadrant 4, but there are certain values that this is not going to find. For instance, something like 300 degrees, which would be in the 4th quadrant, is not going to be in this because 300 degrees is not going to be inside of my interval from negative 90 to positive 90. An easier way sometimes to look at this restriction is to look at a number line restriction like we used to look at our graphs for all of our 6 trig functions. And we understand that at my y-axis, this is my coordinate 0, the coordinate 0, 0, negative pi over 2 or negative 90 is going to be back here, and positive pi over 2 is going to be here. So the only angles I'm going to be able to find by using these 3 trig inverses is going to be the ones that are in here, the ones that are between negative pi over 2 and positive pi over 2. We'll discuss this a little bit more in class. Now, the other restriction is going to be for cosine inverse, secant inverse, and cotangent inverse. These restrictions are all going to occur between 0 and pi. Of course, we understand that that's in radians. If I'm working in degrees, that's going to be from 0 to 180. Looking at the unit circle, that means that we're going to begin at the value of 0 and we're going to end at 180 degrees or at pi radians. So these are the only angles that cosine inverse, secant inverse, and cotangent inverse are going to find for me, the ones that are on the top half of the circle. If we were looking at the number line again, this time we would start at 0 and we would end at pi or at 180 degrees. And again, that side note for cotangent inverse, I cannot include the end values. Those would be undefined. Now I'd like to run into a real quick example, actually 2 examples, but before we head into the examples, notice that I've got some tips for you. Tip number 1, you have an inverse, go and rewrite that inverse to look normal. Tip number 2, use your unit circle to find all of the places where this is going to occur. And then tip number 3, cut out any solutions that don't meet your restrictions, one of those 2 restrictions. So I want to look first of all at number 16. So tip number 1 for number 16 says go and rewrite it normally. We don't want to look at it as an inverse. We want to look at it normally. And notice the directions were to find the exact value of my angle y in radians. So writing it normally, this is going to be cosine of y is equal to 1/2. This is using the definition, the very first thing that I gave you at the beginning of this video. So write it normally. Number 2, find all the places on the unit circle where this is going to be true. So I have 2 places on my unit circle where my cosine value is equal to a 1/2. Since I'm working in radians, this is going to occur at pi over 3 and 5 pi over 3. And then tip number 3, you want to throw out anything that doesn't meet the restriction. Remember that cosine inverse restrictions occur only on the top half of the circle. So that means we're going to throw out the 5 pi over 3 and we're going to keep the pi over 3 solution. So my angle y is only going to occur at y equals pi over 3. For number 38, the second one that I'd like to do, this one we've changed, and we want to find the exact value of my angle theta in degrees. So once again, take your theta and simply rewrite it normally. Take your inverse and rewrite it normally. So that's going to say sine of theta is equal to 0. And then we're going to look at all the places on the unit circle where this is true. So we understand that this is going to occur at the 2 values on the x-axis. Now remember, the third thing that we want to do is find all those values, and that's going to be at 0, pi, and 2 pi. Now unfortunately, we can't use these values because these are radian values, and my directions say that I should be working in degrees. So this is actually going to be at 0 degrees, 180 degrees, and at 360 degrees. Being careful to follow the directions. And then tip number 3 says that you want to throw out anything that doesn't meet the restriction. Sine inverse is only on the right-hand side of the circle, so automatically you're going to throw out the 180. Now, be careful because you actually also need to throw out the 360. And that's not so obvious on the unit circle as it is on the number line. Remember that on the number line, the restrictions for sine begin, since I'm working on degrees, I'm going to use degree values. The restrictions start at negative 90 degrees and end at positive 90 degrees. 360 is way down the line. It is not inside of this interval. So I also need to throw out that 360 degree. The only angle that's going to be in my interval is going to be the 0 degrees. So that's going to be my angle theta is at 0 degrees.